All right, so we're going to make a quick video, 6.1 versus 6.2 T distribution versus the Z, right? When do you pick to use Z scores and when do you use T scores when finding the margin of error and using that to find confidence intervals? So I'm going to go to my PowerPoint here. I think the easiest way is going to be just to show you a flow chart. I made this flow chart a while ago. I think it really helps, and I would definitely take this down in your notes. And every time you go through a similar problem where you have to decide Z or T, this is what you want to be looking at. So first question, when you get a distribution, is your sample size N greater than or equal to 30? If it is, you will always be using the normal distribution with Z scores. It doesn't matter whether you know sigma or S, right? They're interchangeable as long as N is greater than or equal to 30. If no, you got to ask yourself a second question. Is the population normally or approximately normally distributed? So in this case, in the problem, somewhere in the directions, it would have to tell you that the distribution is normally or approximately normally distributed. If it's not, you can't use the T distribution or the normal distribution, so no Z or T. We're done with the knowledge that we have. If yes, you ask yourself another question, a third question. Do you know sigma? So do you know the population standard deviation? If you do, then you can still use Z-scores with a normal distribution. If you don't, that's when you use the T distribution with the T-scores, right? So all of these outcomes go to either T, Z, or not possible. 2 of the 4 go to Z, 1 of the 4 goes to T, and 1 of the 4 goes to not possible. So if N is greater than 30, Z. If it's less than 30, but you know sigma and it's normally distributed, still Z. If it's normally distributed less than 30 and you don't know sigma, then you have to use T, right? So hopefully this helps. The problems you're going to do today, you're just going back and forth. Is it Z or is it T? If you look at an example here, right, it says this one we have 25 newly constructed houses. So right off the bat, we're less than 30, we drop down. Down here it says it's normally distributed. That's a yes, we continue on. And it says that the population standard deviation. So we do know sigma, so that kicks it over to using normal distribution with Z-scores. Right, as long as you ask yourselves the questions in that flow chart, this isn't bad. So normal or T, Z or T, says 12, so we're less than 30, we drop down. Assume a normal distribution, so that's a yes, we drop down. Sample standard deviation, so because sigma is unknown, we go down and that is going to be a T distribution. For this one, sample size of 22, so we go down, that's a no. It says down here, normal distribution, so that's a yes, we continue on. And it says the actual standard deviation. Whenever it says the actual standard deviation, that means the population standard deviation. So because sigma is known, that's going to be a normal Z-score is what we would use for that. All right, so that's what the problems are going to look like. Same math as 6.1 and 6.2, it's just now the distributions are combined. 6.1 was all of the normal distribution with our Z-scores. 6.2, the beginning that we did last week was all T-scores with the T distribution. Now they're going to combine them together. You have to decide. If you keep that flow chart in mind, I think it should be pretty easy. So hopefully this video helped. Hopefully you enjoyed it. Make sure you like and subscribe, and I will see you next time.